Okay, second example. We have a ball coming down to have an impact with a fixed surface, bounce off. So its initial velocity is 12 metres per second at an angle of 75 degrees to the surface. And then the velocity here is v. And mass of the ball, 0.2 kilograms, and E is 0.5. And the first thing I want to do is find the impulse acting on the ball. So first of all, we need to just think about which way is the impulse going. So it acts perpendicular to the surface, and it's going to be affecting the ball in this way. So impulse on the ball. So impulse is change in momentum, and it's acting perpendicular to the plane. So we can ignore anything parallel to the plane, essentially. And so if you think about your components acting down this way, we've got 12 sine of 75. And then acting up this way, we need to work this one out, but I'm going to call that V perpendicular, but you can call it what you want. And we can use restitution to get to this. So coefficient of restitution, speed of separation over speed of approach. So it's kind of good just to show what you're doing. So even if you just do that, so 0.5 is equal to speed of separation over speed of approach. And so speed of separation is equal to 6 sine 75. So I now have that as being 6 sine 75. Impulse is acting perpendicular to the plane, so it's the change in momentum. We're only interested in the components parallel to that impulse. And so you can just sort of resolve perpendicular to the plane, and we know that the impulse is equal to mv minus mu. The only thing you've got to be a little bit careful of here is with sine, and so we're not working with speeds now, we're working with velocities, and so impulse does have a direction, but because we're just working perpendicular to plane, we're just in one dimension again, and so you need to take a direction as being positive, and it would make sense for the positive to be in the same direction as the impulse. And so impulse is equal to m, which is 0.2 v, minus mu. But u is acting in the opposite direction, so this is minus 12 sine 75. So just be really clear about this. When you're doing restitution, you're working with speed, so it's just the magnitude of these. Impulse has a direction, and so you need to think about that positive, negative direction again. And if you work that through, the impulse comes out as 3.48. And that's perpendicular to the plane. And then the second part to this question was finding the loss in kinetic energy. which is probably an easier bit really. Just the only thing to think about through here, so parallel to the plane, we've got 12 cos 75. And then this doesn't change through here, so this is also 12 cos 75. But kinetic energy is working with speed again. It's just all a little bit subtle. So the initial kinetic energy is equal to a half v squared, which is 14.4. The final speed is equal to the square root of 12 cos 75 squared plus 6 sine 75 squared. And that's obviously a calculator answer button type scenario. It takes us to there. And so the final kinetic energy is equal to a half v squared. And that comes out as being 4.323. And then obviously the loss in kinetic energy is final, initial minus final. So loss in KE comes out as being 10.1 joules. So it's just splitting it into components. The only other way you could possibly think about working with this, so for question A, just to give you another way, I quite like this, I think. This feels more intuitive. But you could set it up as vectors if you wanted to. So you could think, well, that final velocity, well, no, let's start with the initial. The initial velocity is 12 cos 75, but you still need to think about having a positive and a negative direction. So minus 12 sine 75. And then the final velocity, this component is unchanged horizontally, so that's 12 cos 75 still. Coefficient of restitution is a half times 12 is 6, but it's going up, so that's 6 sine 75. And then you can do impulse equals change in momentum. So this is a bit more like what you were doing last lesson. So if this feels good, then do it. I just think, in a sense, this is thinking about it in more of a mechanics way rather than relying on the vectors to do the work for you, which I think might not be a bad thing in mechanics. I forgot what I'm doing now. 12 cos 75. And then minus 12 sine 75. And if you work all of that through, then you actually end up with 0 and on the top, because you've just got this one minus this one on the top, and then you get 3.6 sine 75 underneath. And then that will obviously give you the same answer. So you can sort of set that up in vectors form. But I think really it's just this idea that the impulse is acting perpendicular, so you only need to consider these components when you're looking at what's happening with the impulse, but make sure you give them a sign. So impulse is dealing with velocities and not speed. I hope that's clear.